All right, well, trust you did well on your quiz. We'll be taking a look at it in our next lesson, not live on camera, but we will in here. And obviously I'll get back with you if you're taking it via YouTube. Well, let's go ahead and go all the way back to the beginning of the year now as we begin reviewing for your final exam coming up in lesson 168. All the way back to the very beginning of the book when we first introduced physics and we said, what is physics? Obviously it's a branch of science. What does it deal with? Interaction between two things. Matter and energy. Physics is the interaction between matter and energy. We said that there's a couple key reasons why we study science at all. One of them is so that we can understand better, and hopefully you feel like, having gotten through the year, you understand how things work, why things work the way they do a little bit better now. And you can better yourself as a result. The other reason is because God chooses to reveal himself and his works through his creation. What do we call this?
Special revelation.
The other one. General revelation. God generally reveals there's got to be a designer. This is too intricate. This is too amazingly designed. Things run according to mathematical principles too perfectly for it to have just happened, right? There's got to be some designer. There's got to be some thing that set everything in motion, for everything to work the way it has this year, for everything to go mathematically. There's got to be a designer to this. That's general revelation. But we don't really know who he is, or we would not know who he was or who he is without Jesus Christ coming to this earth, showing us who he was, and then giving us his word so we can know more about him. His word is referred to as God's special revelation, right? So general revelation versus special revelation. Let's see. Units of measurement. There's a lot of different units you've talked about this year, but there are 7 fundamental units that other things are based off of, right? For instance, we say that velocity is measured in meters per second, but that's based on a couple of key units. It's based on the unit for length and the unit of time. Second, we also have units for electric current. Ampere is a basic fundamental unit. Temperature. Kelvin is the SI fundamental unit. Mass. Kilogram. Not the gram, but the kilogram. Amount of a substance. Used more in chemistry than physics, admittedly. Mole. Mole. And luminous intensity we didn't actually get to, but do you remember by any chance? Candela. Candela, you won't have to know that for the exam. Talked about scientific notation. We've used that all year. Dimensional analysis we've used all year. Sig figs we've been using all year. When we've taken our measurements, of course, we round to the number of significant figures as appropriate because we don't want our answer to look more detailed than it really is. What refers to a value being just perfectly exact? The exactness of a measurement. Accuracy. What refers to if you were to take the same measurement multiple times just to make sure it's right, right? What's the old thing saying, measure twice, cut once, right? Measure twice, make sure the measurement's right. Well, if you measure and then you get a different measurement the second time, you should probably measure a third time. Just make sure, okay, which one is it? Consistency in measurement is referred to as, not accuracy, precision. Precision is consistency. Now we want both, right? We don't want to consistently measure wrong, but we want to be precise and accurate, of course. If you do keep getting the same answer over and over when you measure, but it's consistently wrong, I think of, bless them, some of our science experiments in the STEM fair. As I was looking them over, I'm like, there's no way these measurements are right. This may be the average of all the measurements, but there's no way this number's right. They must be doing something wrong. If you use a wrong process, we refer to this as what type of error? Systematic error. Your system, the way you're doing it's wrong. Or maybe the instrument's messed up. We had the pine car derby in master clubs. You know, make a little pine car, run it down there. And Timothy won first place in his age group and gender. So you had, the guys broken into age groups and the girls broken into age groups. And Renee got second place in her age group. Renee got second place, and her car was faster than Timmy's. He got first place in his age group. And I'm like, how does my son win first with a slower car? And it made me wonder, did something go wrong when maybe the mechanism, like the release didn't quite release all the way, and so all the cars were held up? Or how did all the cars, like I could see my son's car being slower than his sister's, perhaps. That's a possibility, right? But for all of the other people in his age group to also have slower cars, that just seemed funny to me. So I wonder, was there systematic error? Was the way they were doing it wrong? Was the timer messed up somehow? I don't know. I wasn't there to know. I just saw the numbers, and I was very confused by the numbers. But it's okay. Timothy's happy. He got a first place ribbon. Chloe's happy, or Renee's happy. She got a second place ribbon. Chloe didn't care. All right. Bless her. There's other types of error that just freakish things happen, right? Like, somehow one car flips on the track when it's going down, or you zap yourself when you're trying to take an electrical read. I don't know. Stuff that can't be avoided is called random error. Anything that has mass and takes up space is called matter. The property of matter, that it tends to retain its motion unless some other force intervenes. Inertia. The amount of inertia in an object. Mass. It's easier for me to change Kendall's motion than Michael's motion. He has more inertia. He has more mass. What refers to the pull of gravity on an object's mass? Weight. The weight of the object. What's the ratio of an object's mass to its volume? Ratio of mass to volume. Density. Density. Right, so if we have two boxes and they're the exact same size, one is filled with packing peanuts, the other is filled with textbooks. Same volume, different mass, different densities. 4 states of matter. Solid, liquid, gas, and plasma. Gases and liquids collectively can be called fluids because they have no definite shape. Basic building block of all matter. Every year people try that. That's proteins. Atom. The atom is the most basic building block of all matter, is the atom. Tell you, chemistry dies hard, doesn't it? Amino acids. Every year. Chemical combination of 2 or more atoms. Amino acids. No, molecule. You got it. Molecule. As we look at an atom, the number of protons gives the atom its atomic number, and that differentiates what substance you're dealing with. The number of protons and neutrons, on average, accounting for all isotopes, it gives us the mass number. Obviously, if you change the mass of an atom without changing the protons, that would be an isotope. We skip a lot of stuff here, not a lot from that, but it'll be on the final. Most abundant state of matter in the universe, believed to be plasma, most abundant state of matter on planet Earth. Well, that's not a state of matter. Liquid. Liquids. And all substances to an extent would have this. The attraction between molecules of the same substance. Adhesion, attraction between molecules of different substances. Cohesion. Adhesion and cohesion help to explain why some things can not necessarily float, but they rest on the skin of the liquid. A liquid tends to have the least surface area possible. Surface tension. Surface tension. And it also explains why a liquid will generally rise in a narrow tube. Capillarity or capillary action. Any push or pull on an object.
Force.
And we said that a liquid always exerts a force in what direction? Perpendicular to any surface, or what was that term? Normal. We'll pick up there in our review in our next lesson. All right, have a wonderful rest of your day, and you are dismissed. No homework other than be studying.